bread that we eat every day in our houses. And then we have all over the life cycle, we use energy and water here. We have input and output, we have waste, we have some process until we finish the cycle over the or on the different stages of the system, and we send a landfill. We send to landfill all the materials or waste, but we are trying to avoid this according with the circular economy thinking, because the landfill is the last step of the pyramid or hierarchization in order to avoid. The most important is to reduce the use of energy, water, and materials over the system. According with the ISO 14044, we have 4 steps. It's very easy to understand what is a life cycle. The problem is when we are applying the life cycle, because we need so much information and it is too expensive and sometimes a little bit complicated to have the information from the organization or for the industrial ecosystem. There are 4 steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. That's all. We have also the stages, because we can study a system we call upstream, from the extraction to the door of the factory. For example, we have the core, where we produce or transform the water, energy, and materials to have products, and downstream, this is the distribution and disposal or recycling. This is very important when you are analyzing a life cycle, to understand what are the phases. This is a life cycle, stages to do a life cycle, and this is the stages that we need to consider. For example, if you say we are going to do only the life cycle of manufacture, it doesn't matter. Or you can do the life cycle only for the use or only for the disposal and recycle, because this is several stages over the life cycle. For example, a factory here in Costa Rica called me to ask the life cycle of the bottle with water, right? They asked me, we need to understand what is the impact that we are producing over the environment only for our production. So I said, you need to study only the use of energy, water, and some other materials from the door, the material on the door dock of the factory to the dock when the product is finished. So we study only that block, okay, that part of the life cycle. But some other can say me, we need to study what's happening with the impact since the extraction of the plastic from the petroleum, or the produce the plastic from petroleum, the transportation to produce the pellets, and the producing the bottled water, the plastic bottle. This is another kind of life cycle. And also another says, it doesn't matter for me what's happening in the production, or it doesn't matter what happened in the upstream. For me, the most important is what happened with the distribution, or what happened with the disposal of the final material. So the phases of life cycle are, as I explained you, goal and scope definition, life cycle inventory, life cycle impact, and interpretation. We are going to pass over these 4 steps in order to understand what does it mean. For example, the goal and scope definition, the goal is the application. Why we are going to do a life cycle assessment? What is the motivation for this? What is the public goal that we are going uh, what is the public goal for this study? The scope. What is the function and functional unit is a little bit complicated to understand. I'm going to give you some example of this. The system boundaries, we are going to consider what are we going to consider into the system. What is the quality of data? What is the critical revision? Inventory is very important. What is the use of material and energy into the system? How is the data and how is the calculation? And then we have the impact assessment. When we have the energy and material consumption, we can calculate, for example, the uh, the water footprint, the carbon footprint. We can calculate photochemical oxidation. We can calculate, uh, let's see, acidification. We can calculate land use and some other indicators, as I explained you, that we can have from an LCA. And then we have interpretation. In interpretation is an iterative, is an iterative a step that we need to use in all phases. Goal is code definition. We need to interpret. We need to interpret the inventory. We need to interpret the impact assessment, and we understand the the whole life cycle as a whole, como un todo. The goal and scope definition. What is the objective of my study? For example, to study environmental impacts. For example, if you are in a hospital, what is the impact of the water that we use in the hospital? What is the impact of the energy that we use? What is the impact of the, let's see, energy use and the material we use to guarantee the health of the people that are there, the beds, the sheets, another thing that we are using in the hospital. Why conduct an LCA to understand the impact of a process? Uh, the scope, functional unit, and unit. For example, one bottle of water of 1 liter, system boundary, cradle to grave. I'm going to explain what is the system boundaries then. The audience, for whom is the study? For manager, banks, municipalities. Time horizon, the production registered for 1 year calendar, for example, 2 years or 5 years. It depends on the data that we have in our system. Source and data quality, and data quality, source and quality of data. Primary, if it is taken directly from a process. Secondary, if we don't have directly taken from the process, we can review or we can read some papers in order to have the data related to the process that we are studying. The main assumptions, water treatment is excluded from the process, transportation is excluded, and things like that we need to take into consideration. For example for a bottle of 2.5 liters filled with water that I did this study here in Costa Rica. I put as a goal to evaluate the environmental impact within the production plant of a 2.0-liter bottle filled with water to reduce energy, materials, and water use, for example, or to identify the product performance to improve the production process and quantify hot spots. What is the function of the product? We always, when you practice or or you do a life cycle assessment, you need to put what is the function of the product or service. In this case, to hire a person during a work day or during physical activity, or we are studying the waste management, for example. This is a very common study around the world to avoid illness to people and reduce impact of the environment from organic matter decomposition, and to find, of course, some solutions by composting, by incineration, by pyrolysis, and some other kind of technology that we can use to treat the organic material from the waste management, the waste that we produce every day in our houses. We need to know what we will do with that, because it's too expensive for our government, and also it provokes, or it produces a lot of illness for the people that live around the landfills, etc. Functional unit is a little bit complicated, but it's easy to understand. Is quantify the performance of a product system for use as a reference unit. I'm going to explain you. For example, in Costa Rica, uh, the study that we did 2 years ago, we filled a bottle with 2 liters produced at a plant in Costa Rica. It could be in Malaysia, in Spain, in Germany, Nicaragua, United States, etc. It's the same. So we refer all the use of energy, materials, and water to 2 liters of bottle of water. For example, what is the consumption of one bottle of 2 liters? What is the consumption of water? What is the consumption of energy? What is the consumption of the plastic, etc.? And also, if we are studying, is another example, the municipal solid waste in Costa Rica, 93% of the waste of the municipal solid waste goes to landfill every day. Imagine, I don't know what happening right now in Malaysia. Maybe the rate to landfill is very high too, uh, because it's too expensive and complicated to look for another solution to treat the solid waste. And also, for example, if we are in a hospital, we can found some functional unit in order to study what is the impact of the energy used in a hospital in order to calculate the uh, the carbon footprint, for example, or the water use, etc. It's an interesting tool for you to use in your application field. Try to study this interesting and important tool for your studies. Really, I recommend you. I different functional unit as a reference. Why we use more, or the most common use functional unit is mass, for example, pound, economics, energy, joules, nutritional content, calories, etc. You choose according with the study that you are doing, what is the reference unit that more fit with your study. System boundaries is a set of criteria specifying which unit process are part of a pro system. Select the stage of a system. The system boundary is what are the parts of the life cycle that we are going to include. For example, I can do a study from cradle to cradle. What does it mean? That I extract the material, I use the material over the life cycle, and the waste, I introduce the waste into the system the maximum time in order to avoid the landfill. And also the emission in the different part of the process, emission is a kind of waste, of course. We treat that by filters or any technology in order to avoid the impacts over the environment. This is a cradle to cradle. Cradle to grave, we extract the raw materials and send this to disposal, to landfill. But we have cradle to gate, you decide, or with the stakeholders, with the managers of the company or the director of the hospital, what which is your system boundaries in order to do the life cycle. You can do gate to gate, only manufacturing, as I explained you with the bottle of water, or you can do cradle to cradle. This is the circular economy approach, because all the waste I avoid the the landfill and I try to recycle or reintroduce the material to the system. Scope, another example, for example, in gate to gate, I have the unit process one, plastic bottle producing, blowing. Unit process two, filling bottle with water. Unit three, packaging. That's all. The company here in Costa Rica, FIFCO, asked me, I want to know what is the impact of a bottle filled with water in my factory. It doesn't matter what happened out of my gates or out of my doors. It's very interesting. But other company that fill that produce water or fill water fill it with water ask me to include all the system upstream, the core as in this case, and up downstream. In this case, you can see all the configurations that you can do with a life cycle. You can do cradle to cradle. I think I prefer this because I am aligned. My thinking is aligned with circular economy. Cradle to grave is the landfill. Cradle to gate is the cradle to the gate, gate to gate, gate to cradle, gate to grave. This is the from the factory to the grave, and you have the configuration uh, according with your expertise and according with the funds or the financial that you have to do the study. This is an example of one paper that we did, I don't know, 10 years ago in Barcelona to produce compost from with municipal solid waste. In this case, it's from markets, from vegetables and fruits. We produce the compost and apply in a cauliflower vegetables, no? And then the life cycle focusing on the impact that cause over the environment, the emission of ammoniac, methane, nitrous oxides, and box. We study what's happened with this. We present this in the World Congress in Vienna in 2013. Other considerations on the scope, well, the data quality, the time horizon, the audience, and the substance. You need to take into consideration all these steps in order to have a robust study, uh, the quality of data. You have to do a statistical analysis. You need to take into consideration 1 year, 2 years, 3 years, 5 years. It depends on the how available is the information for your study, the audience, what is the main assumptions, etc. The inventory is very important. Once you have what is your system boundaries, you function and your functional unit, you need to study the inventory. This is the expensive step of the life cycle assessment because you need to measure the information or the data. You need to get the data from the system. So the inventory refers to the consumption of energy, materials, and water within the product system. Input and outputs into the product system. What is the input? Inputs and outputs of energy, resources, and water, and all consumption are internal of the functional unit. The functional unit is the reference unit which you will refer all the input and output of the system. This is another case of the unit process. You have here the product system, your system boundaries. You have here the unit process, what is the part of the system that you are studying. You have here inputs of energy, raw materials, refer. Let's see how I said. This is the functional unit. You refer all the consumption to the functional unit. You have emission to water. You know, I am repeating The thing that I say you 5 minutes ago. This is another example when you have crop management. You have here crop management, harvest, and harvest is the main activity. You have crop management and fertigation, but for fertigation you need production, mineral fertilizer and pesticides, transportation or transport. You have here the consumption and the waste disposal. You see, it's the same thing for all. Here is another. This is the case of one table. Data is collecting a table. In this case, you have the input and output. What is the emission of the process? You need, in this case, fertigation phase. As we have here, fertigation, in this case, you can see here we have it's important
Yes.
another considerations. How is the time right now? We are okay. In some minute we will finish. We have here the mass balance. It's very important because it works with the first law of the thermodynamics. Input and output. Input could be equal to output mass plus emissions. And you have here, in this case, a little bit more complicated example of mass balance. All the thing that goes into the system, it is the same that the output of the system plus waste. In this case, this is another case of inventory. In the calculation, impact calculation, we have to take into consideration two types of impacts, midpoint and endpoint impacts. We will see what is midpoint impact and endpoint impact in the next slide. You select the impact categories, classification and categorization, methodology of impact calculation, and the software that we use to do the calculation. Remember, you have the functional unit, you have the inventory, and you have the impact calculation. I will go a little bit more quickly in this part of the presentation because it's a little bit technical. We have the midpoint and endpoint impact. We have 18 midpoint impact: climate change, eutrophication, acidification, ozone layer depletion, photochemical oxidation, abiotic depletion. We have 18 midpoint and endpoint are classified in three types. This is according with the University of Leiden or the CIMA Pro software. We have three, or scientific community classified the endpoint in three: ecosystem damage, biodiversity loss, and human health. This is a kind of calculation. We have here the inventory. The inventory produce the midpoint impact, and the midpoint impact produce the endpoint impact. You see here the you see here the inventory, the midpoint, and the endpoint, and damage to human health, damage to ecosystem, resource scarcity, etc. And we have here what is the main substance that produce the human toxicity, radiation, respiratory inorganics, climate change, ozone layer depletion. It's very interesting, and you see maybe you identify with this kind of information because we have data for human health. This is the main core of your studies that you see. Let's see a little bit more in classification. For example, the CO2 and the CFC, chlorofluorocarbonados in Spanish. I don't know how I can say that in English, really. These provoke or produce the global warming. Those two produce the global warming. And the CFC not only produce the global warming at all, but also produce the ozone layer depletion. The NOx produce acidification and eutrophication. This is a kind of example. What is the classification that computer do when you uh, introduce the inventory in the system. And also you can do that in Excel, of course, but it's a little bit complicated depending on the how complex is the system that you are studying. In this case, you see, it's very important that equivalence, equivalence units and the impact factor. For example, one molecule of CO2 is an impact factor 1 because this is the let's see, this is the normalized element. But you have here, for example, that the CF11 that produce 3,400 damage higher than one molecule of CO2. You see that the elements produce different kind of impact. You know that the global warming is where the greenhouse gases goes to the atmosphere and they trap it, the radiation, and they um, stay in the land, in the earth, and produce the global warming that produce the climate change. This is a kind of explanation, very quickly or very easy that maybe you understand and you have seen in another courses, but it's very interesting to understand what is the characterization. This is a kind of very easy what the system, the computer system do when calculate an impact on a carbon footprint or a footprint is just you multiply the element that you are emitting to the system per or plus the impact factor. This is the question, very easy. You have the emission and the impact factor and this kind the summatory or the sum of the all emission plus the impact factor give me the footprint of the different elements that the system are emitting. For example, water footprint, let's see, uh, carbon footprint, electrofusion footprint, etc. Okay, this is another complex, or not complex. You can see here how can we calculate the global warming potential. We have 15 kilograms of CO2 and 0.05 kilograms of CFC11. This system have 1,750 kilograms of CO2 in this case. But as you see, how can we calculate according with the impact factor and the production of the element in this kind of system. And also you can calculate the ozone layer depletion, the acidification, and the eutrophication. Of course, we don't have time in this presentation to explain what is eutrophication, what is acidification, and so on. But when you practice the life cycle assessment, of course, you need to understand what does it mean in terms of the problem that they cause over the environment and some chemical reaction that produce these elements. For to calculate the impact, the methodology to calculate the impact, we have different. In this case, we use recipe 2018, but there are several methodologies to calculate the impact. Yes, this is a kind there are many methodology. What is the difference between them is how the uncertainty, how let's see the way how they calculate the impact. This is, but there is no complex. In this case, you choose just one in the system, and they give you, for example, the recipe 2018 comes or came from the CMN 2000 and the Ecoindicator 1999. And you see, I work only with recipe 2018. Regarding the software, you can find here Gavi, Sigma Pro, OpenLCA. There are another in the United States, Earthshift. We use here Sigma Pro, but I can use the three system. I really have experience with Gavi, Sigma Pro, and OpenLCA, but the most common in this area is the Sigma Pro, maybe in Malaysia too. And the interpretation is very interesting. Is the way is we need to explain how we can correlate the inventories with the impact in order to identify which is the element that cause the highest impact in the system. So when we correlate, we identify main contributors, changes in the process, and sensitivity analysis. So, for example, which are the unit, which are the elements that cause the higher global warming potential in each step of the system, and also we can compare one technology with another technology. What is better, the landfill or the incineration? Of course, uh, or 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 what is better to produce compost or organic fertilizer instead of send the material to landfill. Is logical. Is logic that it's better to produce compost that to wear to the river or to the sea. Uh, this kind of decision that you can talk, you can, or this is kind of outcomes that you can have from the LCA. This is a simple example. In this case, we are comparing the packaging to bring my sandwich to the university. Reusable, plastic or aluminum. In this case, you see that the better is reusable. This is the Friambera. This is a kind of, I don't know, box, the plastic or another material to carry out, to carry on my sandwich. In this case, aluminum. Why aluminum is so high according with the study? Because aluminum is a high use energy based material. It's too expensive in terms of energy. They use aluminum to produce a kind of material to bring my sandwich, to protect my sandwich or something like that. In this case, we have virgin material versus recycled material, which is better in this case, of course. In this case, recycled material because it produces the lowest G global warming potential because the emission is lower than the virgin material we have because we have to cut the trees. Um, but in this case, we are using the paper that we used before, so we reintegrate this to the system with the circular economy or the circularity thinking. In this case, what is better, a laptop or desktop? In this case, as it shows, the laptop is better because it consumes uh, less energy than the desktop. And also, but you need to we need to understand what they did in this system because many things happen around this study that I'm showing you. Uh, you need 3 months, 4 months, 6 months, depending on the kind of study that you are doing in order to understand what's happening with this system. This is another comparison. Utility wind offshore versus a small scale wind. It was made in New York, for example, one study. Electricity, comparing the energy that we use in both systems. It's interesting to understand what is the ISO related to LCA. It's very important to have a guideline in order to do an LCA. 40044, guideline for LCA, water footprint, carbon footprint, environmental product declaration. You need to do also eco-label type 3. There are many things that you can do with LCA that is very important. For example, if you are working in co-design, you need to do an LCA in order to see what is the impact environmental claims and declaration type 1, type 2, type 3, the eco-labels, especially is very important. And here we have some learning lesson from LCA. What is an LCA? What are the steps to do an LCA? Why an LCA used for? Do you understand the relevance of LCA methodology? What do you apply LCA methodology in city, factories, schools, and businesses? It's important to have this information. I can give you this presentation for Farah and for you if you need to read about this. But there are many papers. I can give you some papers you need. There are books. There are many information to do on LCA. From now, thank you very much. I think we can, if I don't know how are the time right now. Uh, if you want, we can have some section or some question from you. If you have any question, I am available to answer. Thank you very much for hearing me. I'm sorry for my English because it's not so good. Because I know that you speak English. My country is a Spanish country.
No te preocupes, Roberto.
Muy bien,
Perfecto.
muy bien. Bueno, más o menos, más o menos. More or less, more or less.
All right. Are we going to open for question and answer?
I'm
Any
gonna
question
start.
from the students? Yeah. If you can briefly introduce yourself and where you're from, and you can straight away ask Professor Dr. Roberto the question, please.
Maybe I'm going to Malaysia is in 1 or 2 years in order to share with you
Yeah,
directly
yeah,
this
yeah.
presentation, and we can do an.
I wish there's a magical door where you can. It's so far away, Costa Rica and Malaysia.
It's
Okay,
okay.
any
The
question from the
connection.
students?
Uh,
Yeah,
Hi,
Shahid, introduce
Professor
yourself. Please turn on your
Roberto.
camera, please.
Oh, yeah, sorry. Hi, Professor. So, I have a question.
Please introduce
Yes, of course.
yourself
Oh,
first,
oh.
Shahid.
My name is Shahid, and I'm from UiTM Bursa Alam. This
Uh,
student course Environmental Health and Safety.
okay.
So, I want to ask, in this in this rising modern world, electric vehicle is really common right now, and it's developing really fast. And the resources are coming from the mining, which which is rare earth. So, in your opinion, uh, in the future, does it really will affect the whole world, since the only the only supplier right now is in China.
Mhm.
Yeah. So based on the ecological, what we can relate from the current event.
Okay. Uh, Farah, could you please brief for the question of him?
Mm.
Yeah, is he was asking, Shahid was asking if the electric vehicles, like hybrid vehicles, they're using electricity to fuel up the car. What's the scenario like for the future for these electric vehicles?
Okay. Okay. Right now, I think there are many things around mobility because electric vehicles, uh, when the at the end of life of the vehicles, for example, uh, the cost and the impact of the environment uh, to recycle the battery is very complex. For example,
The battery,
uh,
right? Yeah.
the battery, yes. You know, here in Costa Rica, I think in Malaysia, I
Yeah.
maybe they did the life cycle of the recycling the battery. Is one example. It's very complex because there are 300 materials that heavy metals to produce. And also, we are having several problems right now because when the battery of the car doesn't work, uh, it's very expensive to change that. And also, we are causing an impact on the production, use, and the final disposal of the cars. But I think let's see, let's see this example. For example, if Malaysia decided to change all the cars uh, to electric cars, the fossil fuel cars, you need the energy to move that cars. So maybe you will have to burn fossil fuels to produce energy. Oh, is complex because you are using petroleum to produce energy to move the cars. So, but I think the government are not so clear about this kind of situation. Uh, in Costa Rica, for example, we have energy 99% electricity is 99% from clean energy. But what happened if we have right now 2000, we are 5 million people. It's a small country. And we have right now uh, 2000, uh, let me see, 25,000 cars are electric. But right now we are having problems to move that kind of that quantity of car because what will happen in the future, we don't have the energy to move the cars, despite of they are electric. What happened when a car broke it down and the battery doesn't work? The car is there in a garage or something like that. We don't have. It's too expensive to change the battery. So, in my opinion, are you asking me? I think we have to wait a little bit more time because I want to buy a car, electric car, but I think I am very cauteloso to buy a car because I don't know what happening right now with the cars. Despite of America, European Union right now is changing Norway to electric cars, but we can have another serious problem with electric cars. I think there are not a specific answer about your interesting question, Shahir, because it's a discussion question in classes, in Congress, in everything that we have right now that are having what will happen in the future with the electric cars. But we have right now we are burning petroleum that cause the climate change, and in the other side we have a problem with the electric cars too. I don't know what will happen really in the future. There is no specific question for your interesting question. Very interesting. What do you think, Stefara?
Yeah, I think we have similar concern and Roberto with the battery and its life cycle. Over here in Malaysia, the big chunk of energy is still from fossil fuel and
Yeah.
coal. So we are still very much need to improve on giving clean energy first. Then only all the green vehicles, green products, are making sense. That's how I see it.
Okay.
Yeah. So
Okay.
very good question, Shaheen.
Okay. Maybe the hydrogen is okay. Hydrogeno H. It could be a solution, but and also I don't know. There are some problems because the to extract or to produce the to collect the hydrogen from the atmosphere or the
Mm.
environment is too expensive, and we
Yeah.
need energy, to use the hydrogen in cars. But
Hydrogen.
I
Yeah.
don't know.
Yeah. Yeah.
The world right now is another in an interesting step
Yeah.
in order to
Interesting.
change
Yeah.
to do.
Right. Well done, Shaheen. Any more questions? Yes, Darren. Please go ahead.
Hi, Assalamualaikum. Hello, Professor Dr. Roberto.
Hello.
I am Rashdan. This is my friend's device. Can you hear my voice clearly?
Yes.
Yes. Okay.
Rashdan. Yeah. He's
I
using
have
his
some
friend's device. Yeah.
question. I have some question. For industrial ecology, we do have a few tools such as FMA, material flow analysis, LCA, but they are not compulsory for industry to implement the ISO. So for medium industry, they sometimes have byproduct or waste that can be used for other industry, but it might be far away and it require more cost for management. So sometimes they resort to easier decision, which is to dispose that waste. So what's your point of view or what your suggestion for this issue?
Okay, is another interesting. Thank you. Darren is okay. Darren is
It's Rashdan, but it's okay. He's
okay.
using his friend's device. His name is Darren.
Darren, okay. Very interesting. You are talking one interesting issue for this conference. You're talking about circular economy right now because uh, in the past, community society, believed that the recycling of the material that the byproducts after the production. I don't know if I understand in a right way. If you correct me, Farah, I think eh, all the people 5 years ago said that the recycling was the best way to treat the material after the final life of a product or after the production system. But it's not the best way because when you recycle, you need to introduce energy to the waste. So there are other ways in order to valorize and to treat the material before that you need to compare in order to take a decision. I don't know, Farah, if I understand clearly what the meaning of him, Darren, of if you have something more to ask me. I understand a little bit, 30%.
Yeah, it's Roberto. The concern that we have here in Malaysia, we have many small and medium industries. They are not
Okay.
big industries, because
Yeah, yeah.
and they're having trouble to keep doing good for the environment. So Darren was asking just now if industrial ecology using material flow analysis, using life
Oh,
cycle assessment can actually help to, for them to start something with
okay.
sustainability, with doing circular economy. So I think, yeah,
Oh,
I
okay.
taught them material flow analysis during our
Okay,
last
okay.
class, so they're quite familiar with how to do the
Yeah,
MFA.
yeah.
So for this week they're doing LCA, so there's another tool for that. So I hope the students get some idea on the basic knowledge of these tools and how we can actually use these tools. Of course,
Okay.
ISO 14,000 is like a, you know, an advanced version of it. You know,
Okay.
if you have the capability, you have the resource, you have the funds, I think, yeah, we should go for that. That
Okay.
really boosts up the image of the companies. But with small and medium industries, they are struggling with the, you know, the cost, with the profits. So they want to do, what can they do with their limited uh, capability, you know, with small funds, with small uh, something small that they can do. So I think you answered the question with
Okay. But a little bit, I have another another comment of specific interesting. Okay, let's see. Industrial ecology uh, is a new discipline, as I explained you, that have a lot of tools
mhm,
inside. Chemical engineers or any profession right now can do in uh, small companies as I don't know how pymes in Costa Rica we call pymes,
mhm,
small uh, entrepreneurs or
mhm,
companies that you can apply. But if you see the material flow analysis, for example,
mhm.
it's just what is in and what is out into the
Yeah,
system, and you need a balance.
yeah,
So you can use the the thinking of industrial ecology as a new discipline that was adopted, the thinking by several careers in order to reach the objectives. The problem is, as far as the Professor Farah right, told, the it's expensive to go to a group of companies if you don't have the supporting of the government, because you can do a package, sustainable packaging for industry of packaging or plastic or sustainable mobility, etc. But you need to study in deep what's happening in this industry according, because you can use the let's see, when you have a group of industries, you can study the symbiosis industrial. Symbiosis industrial is the use of energy and materials, the residual waste from group of industries. For example, if you have a small company that produce a kind of heat, this heat can be used by another company. If another company produce waste of organic material, they can be used by another company to produce food for animals for harvest. And you know, this is a kind of tool that we use in symbiosis industrial. Do you remember, Farah? This is a powerful tool, but we have the same problem here in Costa Rica. We are trying to work with small companies, but there are many small companies in the territory, but we don't have the funds to go there with some engineers and some students to do that. We need the supporting by government and some other organizations in order to do the study and to try to encourage the companies to have to look for sustainability or to look for changes in the process to contribute to sustainability. But industrial ecology is a powerful uh, uh, profession or something like that to reach the objectives. Yeah.
yeah. Nicely done, Roberto. Any more questions from the students?
A lot
Perhaps.
of students. Do you have do you have in the course, Farah? Qué bonito is nice. Qué
Ah,
bonito in Spanish.
what is it again?
Qué bonito. Bonito
Que
is
bonito.
beautiful.
Very beautiful.
It's
Yeah.
nice. It's nice to have a lot of students. Right now I am teaching, but I have only 20 students. So
Oh,
I think it's
this
few, but
their
compared with
batch
you.
their batch is around 90 students, and 40 of them enrolled to industry ecology, because industry ecology is an elective course.
Ah,
So
really?
they have other courses they can take. So one of it is industry ecology, my class. So
Ah,
half of
really?
them took the class, and the rest, some of them took other courses.
Okay.
Yeah.
Okay.
So yeah, any more question? Probably from the girls are quite quiet today.
You're lucky because all of you in Costa Rica, uh, little kids are right now in the schools and high school are teaching
Mhm.
English because most of the right now new generations of the students are speaking English
Ah, that's really good.
because we are very close from the United States, and tourism here is a strong economic activity.
All right.
So,
Yeah.
but in my case, I have to study English out of the classes and the
Mhm.
traveling and things like that. But
It's okay, Roberto. I think you have perfectly understandable English. And yeah, for everyone's information, I knew Roberto from my study when I studied in Universitat Autónoma de Barcelona for 2 years.
okay,
So that's how I got to know Roberto. We were in the same research group.
okay.
So yeah, they speak Spanish all the time, and even Catalan. They speak Catalan all the time as well. So I
When I
have
was yeah,
to
I was in
go to you.
I take 2 courses of Catalan when I was there
Good.
last month.
Do
Okay.
you speak Catalan, Roberto?
A little bit,
A little bit. Wow, amazing.
but Malaysian is complicated. Let you know.
It's you can pronounce the word really well, because Spanish and Malay is very similar in the way we pronounce the vowels, like A,
Ah,
B.
really?
Yeah, it's yeah. That's when you said I can pronounce Spanish really good, because I pronounce Malay the same way. So
Ah, very interesting. New for me. Yeah. Farah, you have to come to Costa Rica to learn English, to learn
I want to
Spanish.
go there. It's just so far away. We have to someday. Yeah, or maybe we
Yeah,
can meet halfway in Barcelona then.
yeah, yeah.
Any more question from the student? One more, probably. If not, we can take a photo.
Okay.
No more. Dr. Subra, do you have any comment? Dr. Subra is my comrade in. We have an association called Malaysian Association of Environmental Health, MAE.
Okay.
So today I shared also with my it is an NGO, so they're also in here with you, listening to your talk today, Roberto, because I think it's good for everybody to just get some overview of what LCA and circular economy is all about. We are having that now going on in our cities, in our products. So
Yeah, yeah.
a good overview, Roberto. Perfect. Thank you so
No,
much.
the important thing, Farah, the important thing is that in all the organizations around the world, banks, municipalities,
Mhm.
NGOs, etc., ask for uh, sustainability analysis or environmental
Mhm.
analysis because the planet is suffering a lot with the
Yeah, yeah.
anthropogenic action. But
Yes.
I think uh, we need to take care of the environment because for the future generations,
Yeah.
the planet is warming right now,
Yeah.
definitively. But anyway,
Yeah.
okay, take the picture.
Yeah, take a picture, and can everyone turn on their camera? Right. Who's taking the picture? Please, somebody snap. I don't know how to do that. Shafika, please turn on your camera. Who else? So Rashdan, please take the attendance. Make sure everybody is there. All right. Rashdan, can you help us coordinate the photo session?
We're going to take the picture. So, oh, sorry.
All right.
Okay. Okay.
Okay,
Okay.
sorry.
So we're going to take the picture. We start with formal picture first lah.
All right.
Make sure everyone ready. Open your camera and smile. We'll take it in 1, 2, 3.
All right.
Another one. 1, 2, 3. Okay. Freestyle.
We have an informal one, Roberto.
Yeah, formal one. Ready? 1, 2, 3. Okay, last one. 1, 2, 3. Okay.
All right. Can someone wrap up for me? What do you think of this session? Who would like to share something with Roberto? Anyone?
Farah, they looks very nice. Muy
Really?
bonitos. Muy, very nice.
Yeah.
Smiling, happy. They looks
Jóvenes.
muy jóvenes, sí, young
Jóvenes, yeah.
people. Yeah. Nice, nice.
Okay, anyone? Rashdan or Darren, would you like to say something on behalf of your friends? Wow, everybody's quiet now.
Okay, no problem. We finish the session. It's okay, Farah.
Yeah. And
But
Roberto, thank you so much for your time. I know it's already, I think, almost 12 in Costa Rica, 12 in the morning.
no, this in Costa Rica is 9, 10 p.m.
10 p.m. All right,
We
10
are
p.m.
almost go to sleep.
So I'm so sorry about your health. Thank you. I hope
No,
you
you're welcome.
you will recover really soon. And thank you for sharing your knowledge and
Okay.
experience, your expertise on LCA to the students. And I hope this can become our annual thing. And I'm so happy to see that this time around it's being shared also to not only the students of UITM, to the public as well, with the members of the Malaysian Association of Environmental Health. And thank you again for your contribution, Roberto. And on behalf of my students, I apologize if there's any
No, it's okay.
glitches, problems throughout the arrangement. And I know you are very obliging. Every time I ask you, would do your
Yeah.
best and try to accommodate. Thank you so much for that. And yeah, I think it's really important for us to take care
Yeah.
of the environment together. And I
Uh,
hope we are doing, you know, something
yeah.
beneficial, although very small. We may leave some impact to the society, especially to our young students, for them to
Okay.
understand and act
You're
more
welcome.
responsibly in the future. Thank you so much, Roberto.
Yeah.
And I
The
wish,
future, we can talk a small conference or class of
Mhm.
circular economy. It could be very interesting.
Sure, yeah, we can do that
Yeah,
as
but
well.
we can arrange something in the future. Bye
Yeah.
bye.
Bye
Nice
bye.
to meet
Thank you,
you.
everyone.
Bye
Have a nice
bye.
day.
Bye
Bye
bye,
bye.
doctor.
Thank you.
See you.
Bye bye.
Have a
And
nice
See
evening.
you.
Thank you,
day.
everybody.
See you. Bye bye.
Bye. Dr. Subra, you all right? Thank you for joining us. Bye bye.